Hello children. So today we are going to start with the second section under pandas, data frame. Now you might have already finished the section called a series. That time itself I told there are two kinds of pandas objects. So this one is just like a two-dimensional array, where a series you can consider like a one-dimensional array. So what is the difference between a one-dimensional array and a two-dimensional array? The same difference comes here. That is, here you can store the data in the form of row and column. That means it has two indices, row index and column index. The row index is known as the index and column index is known as the column name. Now, how to create this data frame? The most efficient method is using a dictionary. So, you can concentrate in the first example given here. You have an import statement, then the second statement starts with the dictionary creation. So, student, marks and sports are the keys. And there you have different values inside that. Now, this statement which you can see is the data frame creation. Data frame is a function where D and F is in caps. It is a system-defined function found inside the pandas module. That is why I am invoking it with pd dot. So pd dot data frame takes different arguments. Actually three arguments, but here we have only one argument given, and that one argument is our dictionary. That dictionary is being right now going to be converted like a data frame. So df1 is the object which will store our newly created data frame. So when you give print, this is how your output is going to be. As you can see in the box, your column name are your keys of the dictionary: students, marks, sports. Whereas index is not specified by us, so it's by default starting from 0, 1, 2. Now imagine you wanted to give an index by yourself, but column is to be the same over here. So if the index need to be specified, there should be a slight change in the statement. As you can see here, again the same statement is rewritten, but with pd.dataframe dict1 comma index equal to abc, where here index is your keyword which will specify the index. Now the output would be, see, you can see ABC came as a row index and student marks sports remains with a column. So this is the first example of your data frame. Now second one shows you how to create it in a different manner using a two-dimensional dictionary. So this one is with a one-dimensional. Let's go further. Your two-dimensional dictionary is here. Now I know you are not well versed with your two-dimensional dictionary because we never did such things when we learned dictionary. But here you can easily identify it because four different dictionaries are created with the same key names: CS, ACC, BS, Chem and IP. So everywhere the keys are same. That is the main speciality of these dictionaries. Now another dictionary called a score list is created where your year 2016, year 2018, year 2019, year 2020, which are the four different dictionaries, are given as data values, and a new key is given with 2016, 2018, 2019 respectively. So this way we have created a two-dimensional dictionary. Now the same way as we have done in our first example, here also your data frame takes score list as argument. Once you take your score list as argument, your dictionary gets converted using data frame function, and here the object name of a data frame is used as score sheet. So the output looks like this if you give print. Of course, one statement went up here, you can see here. So what is the specialty? Year 2016, 2018, 2019, 2020, which was your key names of your score list dictionary, became the column name, and the common keys of those four different dictionary which you gave it as inner ones or inner dictionaries we can call it, became the row index. See, CS, ACC, BS, CAM. So if there is a change in the way you have done here, that means if the inner dictionaries has a non-matching key, then in that case no error will come, but there will be a case of NaN. You remember, not a number would be used to fill the missing values. So you can try out, after trying out this example, by specifying different column names. I mean different key names for this particular dictionaries which is specified as the inner dictionary. So let's see what happens when you give it like that, and try to understand the difference between what the example is specified here and what we just discussed. So three examples, one with a single dimensional dictionary, then with a two-dimensional dictionary, and with an index has been over. Now we are moving on to the next creation. Now the next creation is not very common when we do programs, but still you need to know because you have learned NumPy. So how to create this using a two-dimensional array. So in order to create a two-dimensional array, a NumPy is required. So we are importing NumPy and importing pandas together. And you're creating a two-dimensional array with a 3 into 3 matrix style. That is 3 rows and 3 columns. So in NumPy mode, this is how the output looks like. And when you put that into a data frame with NARR1 as the argument, you can have your data frame where you can see 012 012. See, the column name and the row index became the same and your values are here. But this method we will not be using because the main idea of this data frame is to plot graphs. So for that we need some meaningful values, just like we saw in our second example. So this is just for the information, that is by chance in any output question, if a data frame is created using a two-dimensional array, then you can see it. Now let's move on. Suppose what if I wanted to specify column and index. Now this can be specified with any example, but now I am showing this with your two-dimensional array. So you can specify the column names and index explicitly using the same statement. This time 3 arguments are specified properly. See, NARR1, column equal to first, second, third, index 1, 2, 3. That case, your output is slightly changed with first, second, third becomes your column name and first, second, third here in the Roman style becomes your row index. By chance, if you have a mismatch in the column, that means if the number of columns is not matching like this way, suppose if you give it like this way, then there will be a different style of a column name section taken. As you can see here, one column name will be taken by the pandas and this is how the output looks like. That means if you create an array with a not a correct number of columns actually. So 1, 2, 5, 6, 7 is given like this way. Then it won't be showing it in the correct form of row and column. So that means your row and column should match. Suppose if the number of columns are specified explicitly, that means over here if you give column as first, second and you already have 3 different columns, then of course you will be having a problem. So make sure when you try it out, your row and column should be matching with the index names which you are giving. Okay. So let's go further. This is just a sample of your Panda section under NumPy. Now coming to the fourth example. Now the fourth example and the first and the second example you should be keeping in mind because it is through this methodology we will be creating our graphical plotting after this chapter. So what is the specialty here? We are going to create a data frame from different series. That means I am going to use, instead of dictionary, series. So since you finished learning series, now it is easy to understand. For that, the first series, see, purple. The second series is average income short form, AVNCM. And the third series is status. Now again there is a peculiarity here. Peculiarity is that your index here is same. See, I have never specified it as in index here in series, but you know Delhi, Goa, Kerala, Punjab is going to be same everywhere, or I have given the same index in these three series. And as you can understand now, the first one is regarding the population, the second one is regarding the average income, and the third one is regarding the lifestyle status of these states. Now the different series are created. Let's see this one, dictionary. I hope you are able to follow this where I'm pointing to. This dictionary is creating the keys and the data value with the help of the series. So Popul, AVINCM and status, which was your series, are right now the data values, and population, average income and lifestyle are the key name which I have given here. Now if you put that, that is a dictionary is being created using series. If that dictionary is been coming as an argument here, you can see how my output looks like. See, where your population, your average income, your lifestyle is coming as your column heading, and that index which you specified for the different series, that is Delhi, Goa, Kerala, Punjab, is coming as your corresponding row index. So you can see some kind of similarity. This example is having some kind of similarity with the second example, correct? So the second example was using a two-dimensional dictionary. The fourth example which we are discussing right now is using, of course, a dictionary itself, but inside the dictionary you are giving a series. So this one looks like a perfect data frame. So if you compare these two, you will be able to understand how to create. So I want you to go through the second and the fourth once again, understand it, and then create your own example by yourself. Now, before moving on to the different sections, I am just introducing the commonly used functions. So if you want, you can see at a stretch, we'll be taking it once again properly. Now the index can be specified with the help of this index. See, index. So index is specified. Then again, all this index, when you specify, it will come, the index only will be specified. So if you just give it like this, the index is going to be displayed. You can see over here. Okay. So if you specify df1 population, df1 lifestyle, df1 population lifestyle, only those values are going to be displayed. So try to see these things with the help of your example. So after creating your data frame, try to give df1 dot population. So what happens if you give df1 dot population? Only that section will be displayed. What happens if you give print df1 dot lifestyle? Only that will be given. And what happens if you give print df1 population comma lifestyle? Both will be displayed. Now you can also start with your Boolean indexing, but Boolean indexing I will not be taking it in this section, which will be considered later. Now here what we have done is, this is a sample of different functions output, which I will be discussing properly afterwards. So your main advantage of this section is to understand how to create the previous examples. This one, the first one, the second one with your dictionary, and the fourth one. Of course, the third one has to be discussed, but the fourth one. After completing these four only, you move on to the fourth section's example of this kind. So I don't want you to go through this in an elaborate manner during this section. Let this section cover your fourth example, and I need you to go through the fourth section and create different kinds of data series by yourself. Then if you have time, then you can try it with print df1 dot population, print df1 lifestyle, print df1 population lifestyle like this by yourself and see what is the output. So once that is done, Then we will move on to your Boolean indexing. Now this section, as I told, will be discussed later. So I hope you got clear-cut idea.